Hello everyone and welcome back to my YouTube channel. And in this one, I'm going to make here one custom object detection model using YellowB5. So here we are going to build our own custom dataset and also we are going to train it using the YellowB5. We're going to label the images using the label IMG tool and also train the model using Pytorch and Python. I especially make this project for my girlfriend, so that's why it's very special. So I think that why not I'm sharing with you. So without any further ado, so let's get started. So in order to create the custom ULU B5 model, we need to collect the data. So in our case, we have three classes. First one, hello. Second one, I love you. And third one, thank you. Now we need to collect three different images. For collecting the images, we actually using the OpenCV library. So now let's create one Python script and do some coding and let's see how can we collect the images. So for that, I'm going to create one Python file. Let's say data collect.py. Now we are going to first create one camera. After creating the camera, we are going to count the frame. After counting the frame, we are going to actually save it inside our folder. So you can see here one folder that's called images, and inside this images folder, you can see here three subdirectory: hello, I love you, and thanks. And this folder is right now empty. We are going to actually collect the images and also fill it, right? So now let's import the CB2. So in order to actually import it, you need to also install this library, right? So for that, just open your command prompt and type here pip install, and the library name is that's called OpenCV Python. Just install this library on the system and then it will work, right? I'm going to actually close it right now. So first I'm going to import here CB2 because we're going to first create one camera. After creating the camera, then you can actually store it, right? So for creating the camera, we import CB2 already. So now we need to create one video capture object. So cb2.video capture. So if you have any external webcam, you can actually give here your webcam number. But right now I'm going to put here 0 because I'm going to actually using my default webcam that is already attached on my laptop. So now I'm going to actually create one infinite loop. So let's say while true, and also create red frame equal to, I'm going to actually read that. This is simple boilerplate code for the OpenCV. If you are new in OpenCV, you need to also know that how can you create one camera using OpenCV. So now let's say using the cb2.imshow and give here one window name. Let's give here frame, and also let's give here the frame, the variable, this frame variable. Now you need to actually initialize here one keyboard binding functions. So let's say keyboard cb2.writeKey, this one not ex, and pass here one, and let's assign into one variable that's called k. K means this is nothing but called key. So if k equal to ord, because this is infinite loop, we need to also break it. Otherwise, it will running, and sometimes it will also crash your laptop. So that's why you need to also break them, right? Now let's break it and also try to release our video. So let's say cb2.release. And after that, we need to also destroy all the window that is already exist here. Just save it now and just run the code. Cool. I need to run the code, and just a while it will open the webcam. Cool. You can see here webcam is right now on. Let's add the glass. Okay, cool. So now what do we need to do? We need to actually collect the images in this format: hello, love you, and also thanks. In this format, you need to actually collect the images. So now what I'm going to do, I am going to actually create one path. So let's also close it out. So now I am going to actually initialize here one path. Let's say name equal to, that's our path where you're going to actually store the images. Let's say inside this images folder, we have, first let's collect the image for hello, just hello. And let's say one backslash. And let's say we're going to actually collect the image in this format. Let's say our image should be look like that. Hello, let's say 1.jpg. So 1 is nothing but our counting number. That's how many images actually collected here. So let's use str and give here count. But we don't initialize here count yet. So let's initialize here one variable that's called count equal to 0. And let's assign here, yes, cool. And now our extension should be .jpg. Okay, let's remove this now. And also what you need to do after going inside this loop, we need to also increase our count variable to 1. So let's say count plus 1. That's when it will take 1 images after the frame. Okay. Then what you need to do, we need to also store it, right? in our directory. So for that, you're going to use here cb2.im, right? And give here your path and your frame. Cool. Now there should be one problem, because frame is actually it will take the images for in 1 second to take 13 images, but we need to also make our frame should be stable so that we can collect the images. We can actually give the pose and collect the images in better way. So for that, what I'm going to do, we're going to actually sleep our frame after 2 microseconds, and it will, we can actually store into the variables that store into our what you call our directory. Let's say time dot sleep. After this second, we are actually going to sleep, and after it will store the images. So now let's check this out here on the hello folder. We're going to actually save the images. Just run the code. See, it will actually taking the images, right? And what it actually do, it will actually store. You can give here the pose, any kind of pose you can give here, because this hand just you need to actually take the images like that, hello and the love you in this format, and it will actually store all the images on your directory. So now let's check this out, that is really stored or not. Okay, inside our folder we don't get any images right now. Okay, we got one mistake here, because you need to also give your own backslash here. So that's why it's not actually stored these images. So let's run the code again. Okay. Okay, so we need to collect the images in this format, right? But the problem is how many images that we need to collect. So we can also do that. If I press Q from the keyboard, it will gone, right? It will actually break these loop, and it will actually save. But how many images? Let's say we're going to collect the 13 images, and after collecting the 30 images, it will automatically break the loop. We can also do that. See, it will actually store. It actually what do you call? It actually save the images, right? But the problem is how many images that we need. Let's say if the count is 13. Okay, 30 images that you're going to collect that, then it will automatically break. We can also do that. So for that, what you're going to do, you can actually use here count is what it's called. If the count is less than 30, you can do actually store them. If it is greater than, then it automatically you need to break. So or if I trying to press Q from the keyboard, and it will also automatically gone, right? So in this way, we need to actually store the images for hello, also for the love you. You need to just change this here, the image, the name, path name, and also for thanks. So I already actually collect the images before outside my home, and where the lighting condition is very good. But in my case, lighting condition is not so good. So that's why I am not actually using this data set right now. But in your case, you can actually using this script to collect the images and store into in your folder. So now I'm going to paste here some images, just replace it. Okay, and now let's open this here. See, I actually take the images. You can see here, hello. See, my lighting condition is really good, and you can see this for hello. And let's delete this. You can actually delete it from here. And also this one, love you. And you can see here, all the picture is really good in the good conditions, and you can see. And this one for thanks. Okay, cool. Just you need to take the images in this format. Okay, cool. So now what we need to do, we need to create another folder here. That's called train data. So now we need to actually label the images using the label img tool. I'll show you how can you do that. Now inside this train data folder, you need to create another folder that's called images, and another folder that's called labels, right? Now inside the images folder, what you need to do, you need to just go on your folder and just copy all the images, and just you need to paste it inside your folder, this images folder, right? And also do the same thing for love1. Copy this and going to paste it on inside the images folder. Cool, just paste it. And also the thanks one. Cool. So we actually store the all images inside our images folder. See how the directory actually look like. We create a folder that's called train data, and inside this folder we have another folder that's called images and another for labels. Now that's the main thing here. We need to label the images using the label img tool. So here you can actually get your label img tool. It's already available on the Windows, Linux, or you can download it, but it's not available on the Mac, right? It's actually available on the Windows and the Linux. If you're actually using the Mac, you can actually using any kind of online tools for the labeling. So just you need to download it, any kind of version for Windows, or if you are a Linux user, you can actually using that. Okay, but I have also one version that is already on my laptop, so you can also use it. I actually put it on the GitHub. You can download it from here, or you can actually download it this link. Okay. So all right, this is my label img application. It's nothing but 12.8 MB. I actually put it on the GitHub. You can actually download it from here. No problem. Just open this label img tools. And now what you need to do, you need to open the directory. And you can see here it already selected. In my case, just select the folder and change the save dir. And you need to go to select this label 1. You can see images and the labels. And inside this label, you're going to actually select all the folder, right? So now what I'm going to do, I need to change this Pascal BOC to YULU version. Pascal BOC is nothing but for the TensorFlow object detection one. You can also later on you will also discuss about that, the TensorFlow object detections one. So let's use it for the YULU one. So just now what you need to do, you need to actually create the rectangle box. Just create the rectangle box like that, and give here your class name. So this class name is nothing but hello, and you need to save it, right? And click on the next. And just do it for the same. So I already do that and also store into my folder because this is really time consuming, you know. And I already do that, and I also actually take one video clip for that. So after labeling all the images, you can get here this kind of txt file. Here you can see here one folder file that's for classes, where all the classes actually store. Hello, I love you, and a thank you. So now what you need to do, you need to just copy all the files, okay? Or you can say, you can also cut them. And now you need to go on your images folder and just you need to actually paste it here, okay? And you can delete these classes, the file. And now you can see here all the images with their corresponding txt file. So inside this txt file, you can see here some coordinate value. That's been your annotations coordinate. And also you can see here class. 0 class is nothing but for hello. And if I actually open another one, this is for the, you can see here 0. And hello, let's open for this one, love you one. And you can see here 1. And for another one, let's for thank you. And you can see here 2. Okay, cool. So now we collect the images and also we annotate them. Now we need to divide these images into train and the validations. Train and the validations. Okay, cool. So we have 30, 30, 30, we have 19 images. Now we're going to actually take some images for the training and take some images for the validations. Okay. So I already split that in the training and the validations. So I'm going to pass here this file. Okay, so I'm going to paste here one file here that's called train data. So inside this folder, you can see here images, and it have two folder that's called train. And inside this train, you can see here all the images for training, and inside the levels folder with their corresponding levels. Okay, you can see here hello 2, 3, 4, 5, 6 is not there, 8, 9, 10, 11, 14, 15, 16, and the 17. That means 6 is go on the validation part. We actually take some random images, and inside the validation, you can see here the validation levels. And for the images, you can see here all the training images and all the validation images. Cool. So we take the 13 images for the validations, and after the 16 images for the actual training part. Let's say the properties for the 60 images for the training part, right? And with their corresponding labels is stored on the labels folder, this labels folder. Cool. I think it will hope sense to you that how the folder actually look like. So let's repeat it again. So we need to create one folder that's called train data. Okay, inside this train data we have the images with their corresponding label. Now we need to actually break them or split them into train and the validations. Okay, you can choose 80% or 10%. And also you need to create one folder that's called labels. Okay, and inside this label you need to create two folders that's called train and the validations, and also inside the images folder you need to create two folders that's called train and the validations. Okay, this one, so images, train and the validations, and inside the train images, and inside the validation images, and after the labels you can see a corresponding train images and their corresponding label, and their validations, their corresponding labels. Cool. If you have any confusion, you can pause the video or you can go back and see it again. Now let's actually make it trains data, or okay, notes. Let's say just make it, rename it here, because I'm going to actually zip the file as a train data. Okay, that's a train data. Now I'm going to actually add to archive and make one zip file. So to training the model, we're actually using the ULB5, and we're going to use the Google Colab in our laptop. We are not actually going to do that. If you have high amount of GPU, you can also train it on your own laptop. But in this case, I'm actually using the Google Colab because Google Colab is free to use, and if you don't have any GPU, you can actually using this Google Colab. So now just go on the Google and search for ULB5, and you can see your first GitHub link is appear here. Just click this link. Now first you're going to see that how can we detect the object detection using ULB5, and after that you're going to focus on the custom one, right? So you need to actually clone this repo, just download a zip, and after downloading that we can actually using this ULB5 that is already available here, using this you can actually detect the object. For the custom, you need to actually go down and you need to open this in the Colab. So let's try to download it out, and after testing for the object detection, then you go on the Google Colab for the custom object detection for training one, right? So the file is actually downloaded here, and you can see a ULB5 master. So I'm going to actually click here and extract here, right? So if I extract here, you can see here there one file that's called detect. So using this detect.py file, we actually detect the object. And also one file that's called requirement. That's mean how many things that you need to actually install. You can just run this command to install all the requirement. You can see here all the requirement here. And also you need the one library that's called Pytorch, and this should be greater than 1.7. Okay, if you run this program, you need to actually install the Pytorch, right? So on their documentation, they also talk about how can you actually install that. So they talk about Python version should be 3.70 up, and you can see here including the Pytorch 1.7, that's greater than 1.7. And you can also installing this command pip install -r requirement.txt. You can actually install them, and also you need to actually download one model file to actually running this system. That's been running this, okay. And this is ULB5, okay, right? This is not here. So this model file, actually you can go on this release and you can actually download it, ULB5 5pt for the Pytorch. If you're actually using the Pytorch, you can actually download this model from here. Don't worry, actually give this model on the GitHub link or my Drive link. You can actually get it from here. You don't need to actually download it, this ULB5S model. But you need Pytorch to run this program, right? So for that, you need to go on their Pytorch official website, and you need to also install that and make sure that you have one NVIDIA GPU. But Pytorch is also run on the CPU system. You can choose the version that is available here. You can see install the Pytorch. You can use a stable version. I am actually using Windows, and I am actually using pip. If you're using Conda, you can actually using the Conda. And language is Python. You also support on the C++ and also Java, and your Coda version. Okay. If you don't have any Coda, you can select the CPU. But if you have any Coda, you can actually select the version. So how can you check the version for Coda? Just open your command prompt and type here NVIDIA, because I have one NVIDIA GPU, and my Coda version is nothing but 11.2. I can actually choose greater, less than Coda version, and also the Pytorch. Let's talk about the Python version should be 1.7. That's been greater than 1.7 must be. So I need to actually installing this. You can install 10.2. I can install 10.2 or 11.3 is not supported me because my Coda version is 11.2. So 10.2 is supported, or you can also install some previous version of Pytorch. Okay, based on the version you can see here, you can actually download it from a Mac or download it from the Linux system. Okay. And you can see they also talk about the Coda version 11.1. That's also work on me, on my case. But my Pytorch version is not this one. Let's check here. Let's say Python and import Pytorch. Not called Torch, that's called Torch. And my Torch version is, let's check this out. Torch dot underscore version. So this is my Torch version. My Torch version is 1.7.1 and the Coda version is 10.1. So you can actually using these 1.7.1. This version is really stable. Actually, I'm using this one, and Coda version 10.1. You can actually installing this Pytorch version and it will really work fine. Okay. So now let's jump at the code again. So in order to actually run this for object detections, we actually passed here the file that is you can see here ulb5s.pt file. So using this file, you can actually detect the object, and after that, you're going to focus on the custom one, right? So now, in order to run the code, you need to go on here and type here cmd and paste here one command. This command is python detect.py, and weight is nothing but our this weight ulb5s weight, and image size, let's say 64, that's our frame, and the confidence, let's say 20%. If this is 20% up, then just actually select it and detect it, right? And the source is nothing but 0, because we can actually open our webcam and it will open the webcam and detect the objects. So this one not for custom object detection, this one for simple custom object detection like TensorFlow also. Cool, it will open the webcam and you can see here detect me as a person, and if actually using this bottle, right? And it's a bottle. Let's use my mobile phone. And it also say this one cell phone. Cool, that's really cool. So this one for object detections, and you can do it for the custom of the detections. Okay, cool, that's really cool, right? And you can also show the keyboard. Let's say it is actually working here or not. Oh, that's cool, it's the keyboard. Wow, cool. So now let's check it for the custom of the detection. How can you train it, and how can you actually using this, right? Just close it now. So now let's go back, and you can see here train data, the zip file. So now what we're going to do, we are going to go on our ulb5 documentations. Okay, cool. So this is our documentation. Just go open in Colab. And it will open one Colab link. Cool. So now just go down and just run this shell. It will connecting the Colab. Okay, just run this shell and run it anywhere. Okay, so it will cloning this whole repository for ulb5, and just click here the code. Now it will actually cloning the repository, and if you run this one, it will also detect them. You can see here it's already detect person, and this is Jinajit Jidan and Thai, and also you can see a Thai and the person and their confidence value. So now we are actually focusing on the custom object edition, right? So for that, we need to actually pass here the train data file. So now what you're going to do, you can actually copy this and drag and drop inside our Colab file. Just here and upload it. Cool. So it will upload this train underscore data.zip file inside our workspace, right? So now we need to also unzip it, right? So for that, it have one command that's called unzip q, and your path. That's been our path of this train data.zip. So let's actually upload it here. My network is a little slow. Cool. So our train data underscore zip file is actually uploaded here. Just copy the path and just paste it on here, and let's say d dot colon backslash. Enter it here, and it will actually start this file. Just refresh it, and you can see here train data, and you can see here inside this, you can see here images and their labels. Now, you need to go on the EULB5 file, and inside the data file, and inside the inside the data file, you can see one file that's called coco128.yml. Okay, you can just need to actually click on here and download it, and download the file. Now let's open it when it is done. So it will open the file here, and you can see here it is already available for number 80 of classes. So we have 3 classes, right? So let's assign here 3 class and just actually remove it. So our first class is nothing but, let's say, hello, and second one for I love you, and third one for thank you, right? Or you can say thanks. Let's say thank you, and also just actually remove it here, and we need to give here the path of the training and the validation. So we don't need it test one because this is optional, and we don't need this root path, and you can actually give here the train path and the validation path, right? So our train path is inside our train folder. So our train data folder. So train data folder. And inside this train data folder, we have the images and we have our train. And for the validation, this is also same. Just actually copy this out and going to paste it on here. So this one for images and good, and this one for validation, right? So now let's save this file, Control S. And also, okay, let's save this in another name. Let's say save as in different folder. That's in our working directory that you're going to save that, right? So let's give here one file name. Let's say custom data, and just save it. Okay, cool. Custom data.yml and this folder. So now what we're going to do, we are going to actually paste it inside the same folder that you actually downloaded. Okay. So now you just drag and drop the custom data, and you're going to actually paste it inside our data folder. Okay, cool. So custom data is actually passed it on here. So now what you need to do, we need to actually train it, right? So just go down, and you can see here train custom data using RuboFlow. You can actually using the RuboFlow to train the model. Just copy this path and just paste it on here in a spec of using the coco128 YML file. Just paste it, and you can give here epoch sum. Let's run it for 3 epoch now and see that we got any error or not. You can also close it, no problem. So to download the weight from the internet, and you can see this our model, and you can see the model summary. And after that, you will train the model, right? Okay, and you can see here it actually found the 30 images for the validations. Okay, and also the labels, and you can see 16 is found for the training, and also their labels. And it will now start the training, right? Okay, cool. And you can see here this training is right now started, And make sure that you need to check the runtime and change the runtime type should be GPU, must be in GPU, otherwise it should be slow. Okay. So I will train it for 100 epochs, okay, and it will go on the 495 epochs, and then it will actually stopped. And you can see here the labels and their prediction. That's mean their accuracy. And right now accuracy is really low. And if I go on the ULB5 folder, and you can see another folder that's created that's called runs. And inside this run, you can see here train, and you can see here exp. Okay. And inside the wait, you can see here two files, bash.pt and the last.pt. So now I am going to actually run it for 100 epochs. Okay. I can also run it for, so not 100, 1000. If you actually done, you can, it automatically stop. So I already actually trained this model before and also take one recording for that. Just run it now. And after running that, you can also get here two files, bash.pt and also the last.pt. Just you need actually using these two files, or you can use the best one, and you can actually, what do you call it? You can actually test it out, right? So let's start the training, okay? And it will take maybe, it will take 45 minutes in my case. Maybe it will, in your case, it should be or less, maybe. It depends upon your internet connection or you also use system, right? So after training the model, we got here the folder that's in the files, bash.pt. So now we need to go on the runs and go on the train. We need to also create one folder that's called train. Let's say train. And also we need to create another folder that's called, inside the train folder, we have another folder that's called weights. How are you going to actually store the weights? And inside the folder, we are going to actually paste our weights. This is our bash.pt file. So now we're going to actually use this bash.pt file for the testing. Okay. So now what you need to do, we need to actually run the code, right? So for running the code, you need to go on here and type here cmd and paste here this command, python data.py and weights. Weights is available inside the runs and the train. Okay, there should be one another folder that's called exp. I actually forgot to actually create this folder. So let's also create it out. So runs and train, and this not should be the the weights. There should be the exp. And inside this folder, I'm just going to paste it. Okay, now call. Now let's back again. So now let's run the code here. Let's cmd and paste it here, right? So python detect.py, this detect file, and my weight, this is my custom weight that is available on the runs folder, runs, train, exp, and inside the weight folder, you have the bash.pt, and our image size, let's say 640, and the confidence, let's say 0.25%. If the confidence value is greater than 25%, it will actually predict them, or you can say detect them, right? And source is nothing but 0 because you can actually using our default webcam. So it will open my webcam, and now it's time to actually test it out that it's really working here or not. So now our code is working here fine. If I am trying to raise my hand, you can see here hello, and you can see here I love you, and that's called the thank you, right? Hello. Again this one, love you, and that's called the thank you. So that's pretty working fine here. So that's it for today now. Hope you enjoyed the tutorial, and make sure to subscribe to the channels, and also don't forget to hit the bell icon. And I'll be back with another tutorial. So till then, take care and